Let us start today's session, students. Today we'll be starting chapter number 4 of our syllabus. So, unit number 4 of our syllabus is deflection. Okay, deflection. So far, what we have studied in this mechanics of solids is we have seen bending moment, bending stress, shear force, shear stress, and all those things. So those are all strength criteria, students. Whereas if it comes to deflection, this is stiffness criteria. So while choosing a beam or while designing a beam, what an engineer generally see for is see here, if you assume a beam, so we have so far seen all the stresses and forces that are applying on this beam. And the beam paina ఏమేం forces పడతాయి, ఏమేం stresses generate అవుతాయి, we have seen all those things, students, as of now. But all these things, stresses, bending stress, shear stress, and forces, and then principal stress, all these come under strength criteria. So by knowing all these things, we can find, like, we can assess the strength of this particular beam by knowing all these things. Is it right? So that is what we have seen. But now in this class, what we'll do is, students, we'll go into 1 minute, students. All right. Hello. Yeah. So far what all we have seen is, students, strength criteria. That is stresses and forces, and then principal planes, principal stresses, all these things we have seen. But unit 4 discusses about deflection. Okay, about deflection of beams. If we apply some loads, we all know this, if we apply some loads, there will be a deflection here. There will be a deflection in this manner. Okay, there will be a deflection of beam because of the application of loads. If this deflection is visible, if this is visible, it looks unsafe for the occupants. See, uh, see, students, if you are in a building, and your beam is appearing to be bent because of the application of the top floor, పైన ఇంకో ఫ్లోర్ ఉన్నందుకు మీ బీమ్ కొంచెం బెండ్ లాగా కనిపించింది అనుకోండి, మీకు హౌ డు యూ ఫీల్? యూ జస్ట్ ఫీల్ ఇట్ అన్సేఫ్. సో దేర్ ఈజ్ deflection. Visible deflection is very, 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 very more, students. There will be invisible deflection also. Which may lead to internal cracks of the beams. So visible deflection, in a sense, it is very dangerous. Visible deflection, if you are able to see the deflection, it is at the end, it is about to fail. The beam is about to fail if you can observe the deflection. But if there is invisible deflection, that is also a matter of concern for us as a stiffness criteria. That is also a matter of concern for us. Students. Invisible deflection is also a matter of concern for us because this leads to internal cracks of the beams. So that is the purpose why we study deflection of beams. Okay, so unit 4 is all about deflection, students. Is it clear? So now we'll see a relation between this deflection, slope, and radius of curvature of an element. So we'll consider an element. Okay, students. So we'll consider an element, and then we'll write for the relation between. So we'll do this, students. Relation between slope. Okay, slope, uh, deflection, deflection, and radius of curvature. Okay, this is very very important, students. All of you please listen carefully. Only if you can know how I have done this relation, then only we will be able to solve problems very much easily. Okay, so let us consider a beam like this, students. So let us consider a simply supported beam like this. So if you can see here, the right side, this is simply supported beam. Okay, let us consider a simply supported beam like this. So which is going through a force at the center like this. Okay, let us assume there is a force applied like this, and because of this application of force, the beam will deflect like this. So if you can see the dotted line here, this portion is deflected portion of the beam after the application of the load. Now let us consider a small portion in that deflection. Okay, this also called as uh, elastic curve. Okay, deflection curve or elastic curve on పిలుస్తారు. So we'll consider a small portion PQ over here. Is it clear, guys? Is everyone okay with this?
Yes, sir.
Yes, sir.
Okay, now let us take this into this coordinates, students. All of you please observe the left side. I have drawn x coordinate and y coordinate, and I have mentioned PQ there. So I have marked my PQ over here. I have considered just PQ portion and I have marked it here. Now draw the tangents. Draw the tangents at P and Q. I have drawn the tangents at P and Q, and I am assuming that this tangent will make theta angle at the base, and this tangent will make an angle of theta plus d theta. See here, this angle is more. Theta plus d theta is obviously more than theta, that you can see by observation. So as Q is above here, this angle will be more. I am just considering that more as d theta. Okay, this tangent is making theta, and this tangent is making theta plus d theta. Now, uh, so if you just join these two lines, students, like this, these two lines like this, okay, and I assume this to be dy, and I assume this to be dx, and I assume this length to be ds. Okay, is it clearly visible, guys?
Yes, sir.
So now slope can be written as, slope of this PQ can be written as dy by dx, that we know. Okay, slope can be written as dy by dx. Let us not go into that now. So we'll just see only the figure. So I have drawn tangents, and I am assuming the tangents are making an angle of theta and theta plus d theta respectively, and I have joined the x coordinate and y coordinate to meet at a point. So, and I am assuming this length as dx and this length as dy, and length of the arc as ds. Okay, guys. So this ds is very very small. This pq is very very small. This curve pq is very very small, and our assumption is PQ is an arc which is almost a straight line. Okay, which is approximately a straight line. We just, this is an arc, but this is our assumption. Okay, so if you assume like this angle, what do this angle become, students? See here, I have drawn a tangent at P like this, and this is making an angle theta. So if I extend it like this, and this angle will be also theta. Is it right? Is it right, guys? I hope you got my point. I'm just writing this also as theta. Is it clear? Now let us draw the normals at P and Q. Normals in the sense perpendiculars at P and Q. So let us go to P and Q. Let us go to P and Q, students, and then let us draw the normal set P and Q. Okay, so I'm just drawing the normal at P, and similar way I'll be drawing the normal at Q. Normal at Q. Okay, normal in the sense perpendicular to this. దీనికి perpendicular ఉండాలి. సో ఇది అసలు ఎంత యాంగిల్ ఉందో చూద్దాం. This is 36. One. Okay. I'll just use my hand only for drawing the normal. Okay, guys. So let us draw the normal at P. That will be somewhere like this, and at Q that will be somehow like this. Okay. Alright. Is it clear, guys? As of now, okay, right? So if you extend this also, if you extend this, these two will meet. Okay. Even if you extend this, okay, I just wanted to know what is the angle here. What will be the angle there? So as of now, clear, right, students? So there is no complexity. I have just considered this arc PQ. So I have considered this arc PQ, and I have drawn PQ in the plane, considered plane, and I have drawn tangent at P and tangent at Q. So for P I have drawn a tangent, and for Q I have drawn a tangent, and I am assuming this tangent is making an angle theta, and this tangent is making an angle of theta plus d theta with respect to the base. And I am also assuming this PQ as a approximate straight line. So if I approximate that as a straight line, this angle will also become theta. Okay. So now let us write this angle, students. This angle will become d theta. So how does this become d theta? So this angle becomes d theta, and this is what we call it as radius of curvature, and this length is called radius of curvature. Okay, this length is nothing but radius of curvature. All right, guys. So how does this become d theta? అది d theta ఎట్లయినా ఒకసారి చూద్దాం. So I'll just mark it on the right side, students. All of you please observe this. So we have got like this. This is theta, right? And this is somewhere we have got P and Q, and this is also theta, right? Is it clear, guys? And here we have made a normal, that is 90-degree line, and let us just connect these two. Okay, these two in the sense like this. Okay, is it clear, guys? So this angle is theta, and this is 90 degrees. So what will be this angle, students? What will be this angle? This angle again is 90 degrees, students. Here this is 90. This angle, this is all 90 plus theta, so this angle becomes how much? This angle becomes 180 minus 90 minus theta. Am I right? So now what is this angle, students? We know that all sum of all three angles in the triangle is, so we don't know this, అది ఇది just x అనుకుందాం మనము. So 90 plus 180 minus 90 minus theta plus x should be equals to how much? Should be equals to 360. So if you do this, we'll get x is equals to theta. So this becomes theta. Is it right? I'm just remembering, I'm just making you to remember your mathematics corollary. Is it clear, guys? So this is 180, right? Any doubts so far?
No, sir.
So is it okay? So this angle will be d theta. ఇప్పుడు నేను ఇది theta అని రాసిన కదా, సిమిలర్ గా ఇంకొక లైన్ ఉంది మనకు, ఈ లైన్, దిస్ లైన్. అప్పుడు ఈ మొత్తం యాంగిల్ ఏమవుతుంది? theta ప్లస్ d theta అవుతుంది. సో దిస్ యాంగిల్ అలోన్, దిస్ యాంగిల్ విచ్ ఐ హావ్ మెన్షన్డ్ హియర్ will become d theta. That is what my intention is. I hope it is clear for you. I'll just make it once again. So I have just considered like this, and this is theta for me, and there is another parallel line like this. Okay, so ఇది dx అని మార్క్ చేసుకున్నాం కదా, ఇదేమో p, ఇదేమో q, ఇక్కడ theta యాంగిల్ వస్తుంది. ఇది మ్యాథమెటిక్స్ కరాలని మీకు తెలుసు, ఆల్టర్నేట్ యాంగిల్స్ ఆర్ ఈక్వల్ అని. సో ఈ యాంగిల్ theta అయితే ఈ యాంగిల్ theta అయితే తెలిసి, ఇక్కడ p దగ్గర వీ హ్యావ్ గాట్ 10 నార్మల్ 90 డిగ్రీ లైన్ వచ్చింది. 90 డిగ్రీ, దిస్ ఈజ్ ఏ 90 డిగ్రీ వన్. సో ఈ లైన్ ఇట్లనే కొంచెం ఎక్స్టెండ్ చేసి లెట్ us మేక్ దిస్ యాజ్ ఎ ట్రయాంగిల్. ఈ యాంగిల్ ఎంత? ఈ యాంగిల్ మనకు ఫైండ్ అవుట్ చేయమంటున్నాం. ఓకే, ఈ యాంగిల్ నేను d theta రాసుకున్నా. బిఫోర్ దట్ లెట్ us ఫైండ్ అవుట్ దిస్ యాంగిల్. ఈ యాంగిల్ ఏమవుతుందంటే theta అవుతుంది బేస్డ్ ఆన్ ద మ్యాథమెటిక్స్ కరోలరీ. ఇక్కడ చూడండి, ఇది 90, ఇది theta, ఇది ఏమవుతుంది? 180 మైనస్ 90 మైనస్ theta అవుతుంది. ఇదేమో 90 డిగ్రీస్. సో అప్పుడు ఈ యాంగిల్ theta అవుతుంది. ఇస్ ఇట్ క్లియర్? So that is what I have written. If this is theta, this entire angle will become d theta plus theta. So as this entire angle is d theta plus theta, this small angle will be equals to d theta. So that is what I have written here. See here. Is it clear, guys? Only if this is clear, we can move forward. So this becomes theta. This is dy, dx, s, and d theta. So only thing is you have to mark the figure properly. If you have marked the figure properly, it is very, very easy. So shall I erase all these extra things, guys?
Yes, sir.
Okay then. So now let us go into this derivation, students. Let us go into this derivation. So all of you observe this figure carefully, so that based on this figure we'll write the relation between slope, radius of curvature, and deflection. Okay. Okay.
సార్ క్యూ దగ్గర మాత్రమే రేడియస్ ఆఫ్ కర్వేచర్ వస్తుంది సార్, పి దగ్గర రాదా సార్?
లేదు, p దగ్గర కూడా సేమ్ length. This is all same. Radius is same.
ఎస్ సార్.
Okay. This is also r. Oh. This is also r. Okay. So from figure, what I wanted to write is, we can write from figure, we can write ds, length of the arc. Okay, ds is equals to r theta, radius of curvature, into angle that is making. So r into d theta, we can write this and put this as equation number 1. Okay, guys. So ds, length of this arc, is equals to r multiplied by angle that it is making, r into d theta. And let me put this as equation number 1. Also, based on our assumption, మనం ఏమనుకున్నాం, ఇది ఆల్మోస్ట్ స్ట్రైట్ లైన్ ఉంటుందని అజ్యూమ్ చేసుకుంటాం కదా. సో based on that, ds can also be written as, based on Pythagoras theorem, ds ఇది dx ఇది dy ఉంది. ds can also be written as hypotenuse is equal to root of side square plus side square. So dx square plus dy square, we can write it like this, right? So this can be simplified or rewritten as, dx ni common తీద్దాం అనుకుంటున్నా. So if I take out dx outside, this becomes root of 1 plus dy by dx whole square. అంతే కదా? And let me put this as equation number 2. Okay. So based on the figure, these two equations. So only if you can take out this figure and write these two equations, and the rest of the derivation is very, very easy. And same based on the figure, we can write tan theta is equals to tan theta. So if you observe here, red color theta here, tan theta can be written as opposite side by adjacent side. Opposite side is dy, adjacent side is dx. So let me put tan theta is equals to dy by dx. Okay, and let me keep this as equation number 3. So based on the figure, I have written 3 equations. Now let me differentiate this equation number 3. Differentiating equation number 3 with respect to x on both sides. What is d by dx of d theta, students? Tan theta differential in babu,
secant square theta
secant square theta into,
d
so
theta.
this is d theta by dx is equals to dy by dx will become d square y by dx square. Okay, so if you integrate with respect to x, I'm integrating with respect to x on both sides. So now secant square theta can also be written as 1 plus tan square theta. Is it right? 1 plus tan square theta into d theta by dx is equals to d square y by dx square. Now this equation, I just wanted to make it further more simplified. So here we have got, based on equation 3, we have got tan theta is equals to dy by dx. So if you substitute this, 1 plus dy by dx whole square into d theta by dx is equals to d square y by dx square. Okay, since equation number 3, based on the equation number 3, I have just substituted tan place lo dy by dx and substitute this. Now let us also even simplify this, and let us go to our solution. So here d theta can be replaced as ds by r. So how? 1 plus dy by dx whole square into, so I'll just make this dx to move that side, and d theta, so we have got this, students, ds is equals to r d theta. This implies d theta is equals to ds by r. We can write it like this, right? So ఇక్కడ d theta place లో ds by r రాస్తా. ds by r is equals to this dx, I'll take it to right side, d square y by dx square into dx. Is it okay? So I have just wrote like this. Now let me make this ds by r as subject. ds by r is equals to d square y by dx square into dx by 1 plus dy by dx whole square. All right, is it clear, guys? As of now, okay, right?
Yes, sir.
Okay, now let us further simplify and write. So what is ds, students? ds.
r d theta.
So here, if you see here, students, okay, here according to equation number 2, ds is dx root of 1 plus dy by dx whole square. I'll substitute equation number 2 here. Okay, this implies, so based on equation number 2, okay, based on equation number 2, so I can make ds as dx multiplied by root of 1 plus dy by dx whole square by r is equals to d square y by dx square into dx by 1 plus dy by dx whole square. Is it right? So I can write it like this, right? Now let me make 1 by r as subject, 1 by r as subject, so that this term, this numerator term will go into the right side denominator. So if this goes into right side denominator, students, here dx gets cancelled. Okay, dx gets cancelled, and this numerator term I just wanted to make it into downside, so that this becomes d square y by dx square by, so 1 plus dy by dx, this is, okay, so 1 plus dy by dx whole square multiplied by 1 plus dy by dx whole square to the power of 1 by 2, right? Root ni 1 by 2 రాస్తున్నాను, power of 1 by 2 రాస్తున్నాను. So if you do this, okay, a power n into b power n is equals to, sorry, a power n into a power m is equals to a power n plus m కదా, ఇది రాయొచ్చు కదా. ఈ రెండు టర్మ్స్ని ఏ టు ద పవర్ ఆఫ్ 1, ఏ టు ద పవర్ ఆఫ్ 1 by 2, సో ఏ టు ద పవర్ ఆఫ్ 1 plus 1 by 2 అంటే ఏ టు ద పవర్ ఆఫ్ 3 by 2 అవుతుంది. సో దిస్ కెన్ బి ఈవెన్ సింప్లిఫైడ్ యాజ్, this implies 1 by r is equals to d square y by dx square divided by, so I can write this dy by dx whole square whole to the power of 3 by 2. Okay, these two terms have got d by 2. Now this equation here, in beams deflection and slope. So deflection is nothing but y, students. Slope is dy by dx. Okay, so we'll see how and why. Okay, so slope are very small, so we can neglect the denominator. We can neglect the denominator. That is what I'm going to say is dy by dx is very small, very small. So we can neglect this. ఇది వెరీ స్మాల్ అయినప్పుడు, అంటే వెరీ స్మాల్ ఇన్ ద సెన్స్ లెస్ దాన్ 1.0 పాయింట్ సంథింగ్ ఉన్నప్పుడు, ఇంకా 1 to the power of స్క్వేర్ అయితే 1 to the power of 3 by 2 అయితే ఏమైతే, సో ఇట్ బికమ్స్ జస్ట్ 1. It will be equated to 1. So I can neglect denominator. So 1 by r can be written as d square y by dx square. Is it clear? So this is one of the important relations, students. This is the important relation. So if you observe here, okay, if you observe here, this y is the deflection here. ఇక్కడ మనం dy అని రాసుకున్నాం q దగ్గర. ఒరిజినల్ పొజిషన్ ఇక్కడ డ్రా చేసుకుంటే, ఒరిజినల్ పొజిషన్ ఇట్లా డ్రా చేసుకుంటే స్టూడెంట్స్, అంటే ఈ లైన్, ఈ పైన ఉన్న లైన్ ఇక్కడ మార్క్ చేసుకుంటే, this we have taken it as dy, that is the deflection here. This is for smaller portion. If we go for the bigger portion, deflection is y and slope is dy by dx. Okay, so dy by dx or slope can be also treated as theta. So based on here, చూద్దాం ఒక్క నిమిషం, let me go here. So let us come back to this relation, student. We'll move into that also. So this is one of the important relation that you have to remember. 1 by r is equals to d square y by dx square. So from bending equation, students, as the beam is undergoing bending, from bending equation 1 by r can be written as, from bending equation, we have got bending equation like this: E by r is equals to m by I is equals to sigma by y, right? Is it right? So if you consider only this, students, If you consider only this implies 1 by r is equals to m by ei. So let us substitute this, students. This implies so 1 by r is equals to m by ei. So m by ei is equals to d square y by dx square. So if you write for m is bending moment at some point, bending moment. So at some point we can have this equation ei into d square y by dx square. Is it clear? So this is also very important equation. So why did I go for this relation, students? Because if you consider a beam, if you consider a beam, I can write mx, I can write equation for mx at any point, okay, at any section. Any doubts, students? Okay. At any section of this beam, I can write equation for mx. So if you write equation for mx, and if you differentiate this, if you single differentiate this, you'll get slope. Okay, if you differentiate this equation once, you'll get dy by dx. So dy by dx is nothing but slope. Okay. Similarly, if you do differentiation again, okay, double, sorry, integration, students. integrate integrate once and double integrate, we'll get y, which is deflection. Is it clear? So that is why we have derived this relation. So why we have considered only bending, students? The above equation is governing differential equation of the beam and takes into account the effect of bending moment only. So this equation takes into effect of only bending moment. So is there only bending moment? We'll also have shear force, right? బెండింగ్ మూమెంట్ మాత్రమే ఎందుకు కన్సిడర్ చేస్తామంటే, సో ఓన్లీ బెండింగ్ మూమెంట్ ఈజ్ టేకెన్ ఇంటూ కన్సిడరేషన్, consideration. Why? Because the deflection because of the shear is extremely small and usually neglected. So you have to remember this point, students. There will be deflection because of shear also, but it will be extremely small and which can be neglected. Deflection by shear is extremely small and usually neglected. Okay, guys. So usually neglected. So you have to remember this term. So why? Because we have already seen this. ఇప్పుడు మనకు ఒక beam ఉంటే, if you assume all these things like this beam is made of all these strips, and if you apply a load, this deflection is majorly caused by the bending moment. Okay, majorly caused by the bending moment and not because of the shear. So what does this shear do? This shear will generate a force between the strips. So that is shear force, and we have also seen shear stresses and all those things. So deflection is majorly because of bending moment only. Is it clear, guys? You have to remember this equation: mx is equal to ei into d square y by dx square, and this also 1 by r is equals to d square y by dx square. So I have just made use of trigonometry, algebra, and calculus here. Okay, so basics of geometry, trigonometry, and calculus. Based on those things, I have derived a relation between slope, which is dy by dx, and deflection y, and radius of curvature r. Okay, guys. So the only thing is we have to draw this. ఇది మనం కరెక్ట్గా డ్రా చేసుకోగలిగితే we can easily solve for the derivation. Okay. Now there are methods for calculating. There are various methods. For calculating this deflection. So methods for calculating deflection and slope. So they are double integration method that I have just now said you. Double integration, or we can also call it as successive integration. integration method. Okay, and another important method is Macaulay's method. So this method, we have a major focus on this Macaulay's method, and double integration method has some disadvantages based on this Macaulay's method. So we'll see these two methods in our syllabus, and there are also another methods called superposition method అని, ఓకే, ఏరియా మూమెంట్ మెథడ్ అని చెప్పి ఇంకా చాలా మెథడ్స్ ఉన్నాయి. సో దీస్ ఆర్ నాట్ ఇంక్లూడెడ్ ఇన్ అవర్ అకాడమిక్స్ అంటే మన అకాడమిక్ సిలబస్లో లేదు. సో వీఆర్ నాట్ ఫోకసింగ్ ఆన్ దిస్. సో వీఆర్ జస్ట్ గోయింగ్ త్రూ డబుల్ ఇంటిగ్రేషన్ మెథడ్ అండ్ Macaulay's method for finding deflection and slope. Okay, is it clear, guys? So let us see double integration method. So how this double integration method works. So double integration method. So double integration method, students. So we have this equation, the equation of elastic curve అని ఇందాక మనం ఒకటి సాల్వ్ చేసుకున్నాం కదా. So in double integration method, the equation of the elastic curve is integrated twice to obtain the deflection of the beam at any cross section. So y రావడానికి we have this equation, students, ei into d square y by dx square is equals to mx అని ఉంది. So we have got this equation, right? So this equation has to be double integrated to get y. Is it right? So if you do single integration, దీనికి సింగిల్ ఇంటిగ్రేషన్ చేస్తే, సో ఇఫ్ యూ ఇంటిగ్రేట్ ఈవై ఈజ్ ఈక్వల్స్ టు, ఇంటిగ్రేట్ చేస్తే ఇది ఈవై కాన్స్టెంట్ కాబట్టి ఈవై రాస్తున్నాం, ఇంటిగ్రేషన్ ఆఫ్ డి స్క్వేర్ వై బై డిఎక్స్ స్క్వేర్ విల్ బి డివై బై డిఎక్స్ ఈజ్ ఈక్వల్స్ టు ఇంటిగ్రల్ ఓవర్ ఎంఎక్స్ ఇంటూ డిఎక్స్ ప్లస్ సి1. ఓకే, సో integration of constant alone. So this mx is integration of constant alone. So we'll get like this. So this c1 can be obtained by applying boundary conditions that we'll see. So if we even double integrate again integration, so if we apply again integration, this becomes ei into y is equals to double integral of mx into dx plus c1x plus c2. Is it right? Is it clear, guys? I hope you got this. So deflections for simple things can be easily achieved by doing double integration. So in the next class, we'll see for cantilever beams and simply supported beams, this deflection. Okay. Any doubts, students? Any doubts in this class? Any doubts for this class? Please let me know if you have any doubts, students. Is everybody okay with this derivation, today's derivation? Students, please respond.
Yes, sir.
Okay. Any doubts? No doubts? There's a message. Huh? Okay. All right, guys. If you have got no doubts, you can leave the class and join for the next class. So tomorrow we'll discuss. In the next class, we'll discuss about how to do this double integration method for cantilever beams and simply supported beams. So most probably by next week we'll finish up this unit number 4. So this is all mathematics, integrations, calculations only. So I request all of you to please concentrate and put your calci, pen, paper and all those things ready while my class is going on. సో ఇఫ్ యూ డూ ఇట్ ప్యారలల్ టు మీ, నేను చేస్తున్న దానికి మీరు ప్యారలల్గా చేస్తే కొంచెం బాగా అర్థమవుతుంది.